Hey guys, welcome back. I hope you enjoyed our time off because you didn't have an assignment yesterday. So if you were behind on assignments, hopefully you were able to use that to get caught up and, kind of two-edged sword because now you don't have, that's one less assignment you would have had this week anyway. So today's going to be the last topic that we have to teach you over chapter 3. I think you guys are like killing it with this unit over parallel and perpendicular. Like I think this is the best I've ever explained it. So I'm feeling good. Hopefully you guys are feeling good about it as well. We'll take a practice test tomorrow. So you can see how you're actually doing on all this stuff. So we'll plan on taking the actual test either next Tuesday or next Wednesday. And then we also have parent-teacher conferences next week, so we won't actually have school on Thursday, and that'll be the start of fall break. But we do have one more week that we'll do Unit 4 in virtually before we come back. And we're able to be in person for at least half the day. So that'll be really fun. All right, so let's go ahead and get started without any further ado. So here we want to solve for the value of x, y, and I guess technically z. But anyway, on this one, we have parallel lines, so just read the information. We got two parallel lines, we know there. We got two different transversals. We have this transversal, which I can color code. We'll do purple. And then over here, we've got this transversal, which I'm going to color code. We'll do orange. Okay, cool. So on this one, this is going to be 40 degrees. And then what do we know about the angle here? How is x related to 40 degrees? So they are on alternate sides of the transversal, right? One of them's on the right side, the other one's on the left side, and they're both on the interior of the parallel lines. So these are going to be alternate interior angles, right? A, I, A. And we know with alternate interior angles that they have to be congruent. So this angle here has to be 40 degrees, and it is. All right, same thing going on over here with the 85. Now we're on a different transversal, but we still have alternate interior angles, right? So y would still have to be 85 degrees. Now, if I want to solve for the missing angle z, well, we're actually doing two things here. Like if you see, we actually have a triangle. So the triangle in the middle. What do we know about the sum of the interior angles of a triangle? We're actually kind of proving that. I didn't really point it out till now, but we are proving the sum of the interior angles of a triangle is going to be 180 degrees. Well, we also know that because the angle up top here is a straight angle, which of course has to be 180 degrees. So if I add those two together, that's going to be 125. Then I do the supplement of that. So 180 minus 125, which is going to be equal to, I think it's 55 degrees. Yes, 55 degrees. So z has to be equal to 55 degrees. And it is. So the three angles here all add up to 180, and because these two are alternate interior angles, that tells us the sum of the interior angles of a triangle has to be equal to 180 degrees as well. And we did that by using alternate interior angles and parallel lines. So kind of cool. All right, so are the lines parallel or perpendicular? Well, if they're parallel, we know that means they have the same slope. They rise and run at the same rate. That's why they never intersect, as long as they're on the same plane. And then perpendicular lines, they do intersect, but especially they intersect at right angles, and their slopes are going to be the opposite reciprocals of each other. So the opposite means we change the sign, the reciprocal means we flip the numerator and the denominator. So we want to know if these two all have the same slope. Well, the slope is found in slope-intercept form, so y is equal to mx plus b. So if we solve for y, get it by itself, whatever's in front of the x will have to be our slope, and whatever is left over is our y-intercept, which would be our constant. So over here, it's already y's by itself, so we know the slope has to be 4. But over here, we don't know the slope is 1. We don't know what the slope is yet at all, so we have to solve first. So the first thing I'm going to do is subtract x from both sides. I can't subtract 1x from 16, so I just put them next to each other. So I'm left with 4y is equal to negative x plus 16, because the positive is still with the 16, and the negative stays with the x. Then I don't want to know 4y, I want to know 1y, so I divide everything by 4, which is going to leave me with negative 1/4 x plus positive 4. So now that I have the y by itself, whatever is in front of the x has to be my slope, right? So here I have a slope of 4, now I have a slope of negative 1/4. Make sure you know how to solve these equations like this for y. You'll have, I think, 2 problems on the test and the practice test tomorrow. So do make sure, there's a reason I'm going over this again, because some of you guys are still having some confusion on the homework. So anyway, make sure you have that down. Now these two, 4 and negative 1/4, they are indeed opposite reciprocals, right? From positive 4 to negative 1/4, and it's a reciprocal, because if we do 4 over 1, the reciprocal of that would be 1/4. So these are opposite reciprocals, meaning they are perpendicular lines, and if I graphed them out, they look something along the lines of this, except they're going to intersect at right angles. This is terrible. Okay, so hey, look, some beautiful stuff we can look at. So parallel and perpendicular lines, our first line here, y is equal to mx plus b, Our b here is going to be 3, right? So for graphing we're going to write the equation of this line. Our y-intercept is going to be 3, and then our slope, it looks like we're going up 1 over 3. So rise 1, run 3. So that's going to be 1/3. So cool. So anyway, y is equal to 1/3 x plus b, and our b in this case we said was 3, right? Okay. So if I wanted to write a line that's parallel to it, we know it's going to have the same slope, right? Because parallel lines have the same slope. So it's going to be 1/3 x plus b. And the y-intercept actually doesn't matter. You can choose whatever you want. So we can do -1 if we want. As long as it rises and runs at the same rate as this one up here, they're going to be parallel there. So you can do -1. You could have it intersect at 0 and just leave off the b altogether if you wanted to. That technically would work as well. You could do -2, -3, -4, -5, really any number, as long as it's not the same line, you'll be totally fine. All right, the other thing we want to do is a perpendicular line. So perpendicular line is going to have an opposite reciprocal slope. So the opposite reciprocal of 1/3 is going to be -3, okay, or -3 over 1, okay. And then for our y-intercept, we can put that anywhere we want. I think I have it down here. Yeah, so this is going to be the opposite reciprocal slope. So now we're going down 3, 1, 2, 3, and over 1. Okay, down 3 over 1. All right, so it doesn't matter where we put this. You could have it at the same intersection of +3 if you wanted to. That would work out just fine. I don't like that. I like that. Okay, so that's fine. They would intersect at right angles. You could also have it go at 0 or down here at -3. What's also kind of cool here is that if, let's say that intersects and it forms a right angle, so if it's perpendicular to this line, then what do you notice about the other line? Does it have to be perpendicular to that one as well? Yes, because if it's the opposite reciprocal to this slope, isn't it going to be the opposite reciprocal of that one as well? Huh. Kind of cool. That leads me nicely into my next segue, which is called the perpendicular transversal theorem. So smooth. So perpendicular transversal theorem is really kind of common sense. It says that if line 1 and line 2 are parallel, so line 1 is parallel to line 2, so that's shown there, and line 1 is perpendicular to line 3, so line 1, line 3 are perpendicular, then that means that line 2 also has to be perpendicular to line 3. And the reason for that, well, just think about it. If this corresponding angle up here is a right angle, and these are parallel lines, the corresponding angle down here also has to be a right angle. So this is the perpendicular transversal theorem. It says you have two parallel lines and that it is perpendicular to one of them, then the transversal will be perpendicular to the other one. Same thing we saw over here. Two parallel lines with the same slope, right? Both of these have a slope of 1/3. Then the opposite reciprocal slope is going to be perpendicular to both of them because perpendicular transversal theorem. Good stuff. All right, corresponding angles. Remember, corresponding angles are in the same location. So if we notice here, the 1 and the 5 are exactly the same angle. 2 and 6 are the same. 3 and the 7, and 4 and the 8. So the ones that correspond in the same location are going to be congruent. Those angles don't change as we move it up or down a transversal. Corresponding angles theorem states, and look, we have an if and then. This is a conditional statement. Remember, we did the whole logic unit last time. So if line 1 is parallel to line 2, then that means the corresponding angles are congruent. So what happens if the lines are not congruent, then that means the corresponding angles are not congruent. So if the lines are not parallel, the corresponding angles are not congruent, right? And what would that be? Ooh, do you remember if we negate both of them? The inverse. Yes, exactly. So that would be the inverse. So just looking at the conditional here, states that if line 1 and line 2 are parallel, and they are, then that means the corresponding angles, like the top left and the top left here, they have to be exactly the same, and they are. So we're good. Now we can take the inverse of the converse of the corresponding angles theorem in order to be able to prove that the lines are indeed parallel. So the converse, remember, is shoes on the wrong feet. So all we're doing is switching the order. So if the corresponding angles are congruent, then we can prove that the lines have to be parallel. So this is how we prove lines are parallel, this case by using the converse of the corresponding angles theorem. So if I know that the corresponding angles are both 112 degrees, then what does that tell me about the lines? Well, if the corresponding angles are congruent, then the lines must be parallel. So my conclusion is now that these lines must be parallel. So, pretty simple. All right, here's the alternate interior angles theorem. It says that if the lines are parallel, and they are, they're shown in the diagram, then the alternate interior angles have to be congruent. So the alternate interior angle here would be on the alternate side of the transversal. So that's on the left side, this is on the right side, and they're both on the interior of the parallel lines. Okay, so this alternate interior is going to be this one here, and they would have to be congruent. Now the reason they're congruent is because the the corresponding angle down here, 112, okay, bottom right, is vertical with the alternate interior, which means this angle has to be 112. Okay, so if the lines are parallel, then by the by the alternate interior angles theorem, the angles have to be congruent. So the converse of the alternate interior angles theorems, we just switch the order. So if the alternate interior angles are congruent, then the lines have to be parallel. So if I tell you these two alternate interior angles are congruent, they're both 112, then what does that tell us? It tells us that the lines have to be parallel. We can conclude that by the converse of the alternate interior angles theorem. Same thing with the alternate exterior angles theorem. So if the alternate exterior angles, if the lines are parallel, then the alternate exterior angles have to be congruent. So we could prove they both be 112. So then we can use the converse. If the alternate exterior angles are congruent, then we know that the lines are parallel. So if I give you two alternate exterior angles and you see that they're exactly the same, then we can conclude by the converse of the alternate exterior angles theorem that the lines have to be parallel to each other. And same thing with same side interior angles theorem. So if the lines are parallel, then the same side interior angles must be supplementary. It's kind of odd because there's two there. Anyway. So here we have two same side interior angles. We can see that because they're both on the same side of the transversal, but the interior of the parallel lines. So they must be same side supplementary if the lines are parallel. So we can use the converse to prove the statement, or to prove that they're parallel. So if the same side interior angles are supplementary, then, oh, that's why I did it, because it would be redundant. Then we know that lines are parallel. So here we have two same side interior angles. If we add them up, 112 plus 68 is going to be equal to 180, which sure enough is supplementary. So that tells us that these lines have to be parallel to each other. All right, so that was it. Super simple. If you'll get out your assignment, we'll go ahead and go through some of the problems on there. So on number 1, we want to state which lines have to be parallel by the converse of what statement. So these markings here are congruency marks, just like if we had a triangle. So if I had a triangle and I put markings on it like that, that would tell us that those three sides are congruent to each other. The same thing is happening with these angles here. We're assuming that this angle is going to be congruent to this angle. So first of all, what kind of angles are they? Well, top right. So they are corresponding angles. So by the converse of the corresponding angles theorem, what lines have to be parallel? Well, when we're doing this, first thing that's easiest is just to figure out what is our transversal. So what line connects these two angles? Well, clearly that's going to be line T, right? So line T is our transversal. The only thing we have next is what other two lines are being related by these two angles. So that would be D and E. So D and E would be parallel by the converse of the corresponding angles theorem. What you can also notice is that these two angles don't have anything to do with line S. I should actually probably change the color on that one. They don't have anything to do with line S, right? So there's no way that these two angles could be used to prove that S and T are parallel to each other, but rather that D and E are parallel to each other. So you can also figure out which lines are parallel by eliminating the line that is not being, that the two angles are not touching, okay? We don't know anything about what's going on with the angles up here, right? We have no idea. The only thing we know is these two angles, which relate D and E to each other. And of course, they're parallel by the converse of the corresponding angles theorem. All right, number 3. So first thing we want to look at is what kind of angles are we dealing with? You could also say, okay, well, this is our transversal. It's going to be OU, UO. All right, this is going to be on, both of these are exterior angles, right? So we're on the outsides, and we're on the right side and the left side of the transversal. So they're alternate exterior angles. So that's the theorem that we're using. And if the alternate exterior angles are congruent, which is what those markings are showing, what two lines have to be parallel? Well, again, these two angles are relating RP to SQ. The line that they tell us nothing about is NT. We don't have any idea what's going on with the angles over here. So we can say that RP is parallel to SQ by the converse of the alternate exterior angles theorem. All right, our club is designing a new flag for the marching band. In the diagram, the measurement of angle 1 is going to be 45 degrees. The measurement of angle 2 is also 45 degrees, and angle 3 is 145 degrees. Does the flag contain 3 parallel lines? Well, if we look at these 2 lines here, how are they related? Well, those are going to be alternate interior angles, which means they have to be congruent. Are they congruent? Yes. So we can say at least these 2 lines, I guess I could label them here, lines 1 and lines 2, dyslexia is the worst, would mean that these 2 have to be parallel. But are they parallel to this line over here? Well, let me change colors because I can. If we look at this line and this line here, those are on the same side of the transversal and the interior of the parallel lines. So they are same side interior angles, which means they must be supplementary. So if I add them up, 145 plus 45 is actually going to be equal to 190, which is not the same as 180. So they are not supplementary. They're more than that, which tells us that these lines are not parallel. So we have 2 lines that are parallel, but this line is not parallel to the other. In fact, they would intersect if we kept going on. So does the flag contain 3 parallel lines? No, it contains 2 parallel lines. All right, and we were able to prove that by the converse of the alternate interior angles theorem and the converse of the same side interior angles theorem, by the way. That's how we would explain it. All right, number 8. On this one, look at the 2 angles. It looks like one is on the right side of the transversal and the other is on the left. They're both on the interior. So what kind of angles are we dealing with? Alternate interior. Now, in order for alternate interior angles to be the line to be parallel, we have to have congruent angles. 56 is congruent to 56, which tells us that these 2 lines are going to be parallel. So that would be U is parallel to V, and so we could actually mark that here if we wanted to. So U is parallel to line V by the converse of the alternate interior angles theorem. All right, number 20. Now on this one, once it asks for what value of x would R and S be parallel. So first of all, look at the angles. What kind of angles are these? You might at this point just be able to visually tell these are alternate exterior angles, so AEA. That did not work, and that is wrong. Uh-oh. I hope this is not a sign that I forgot to update other stuff. But anyway, which means that they have to be congruent, right? It's the same side interior ones that are supplementary. Everything else corresponding, alternate interior, alternate exterior, vertical, all of those are going to be congruent. So when these 2 are congruent to each other, in other words, when 2x plus 6 is equal to 42, that's going to be the value. That value of x is going to be what makes these lines parallel. So next step I would do is subtract 6 from both sides, which gives me 2x is equal to 36, and then divide both sides by 2, which will leave me with x is equal to 18. So when x is equal to 18, we know that the lines R and S are parallel by the converse of alternate exterior angles theorem. 21, do another example. So on these 2, the arrow tells us we're dealing with the inside angle here and here. So these are on the same side of the interior, right? They're both same side of the transversal and the interior of the parallel lines. So these are same side interior angles, so converse of SSI, which means that they have to be supplementary. So what we're going to do is we're going to add the expressions together and set them equal to 180. Combining our like terms, we're going to subtract. It gives us 81. And then subtract 81 from both sides. So we have 3x is equal to 99, divide by 3, so x is equal to 33. So when x is equal to 33, these 2 expressions are supplementary. They add up to 180, which means that the lines R and S are parallel by the converse of same side interior angles theorem, because the same side interior angles were supplementary when x was 33. All right, 26 says angle 11 is supplementary to angle 16. So 11 and 16 here. So these are same side exterior angles, just like same side interior. They have to be supplementary, and they tell us they are supplementary. So what lines can we conclude are parallel? So our transversal in this case would be y, right? Y is going to be the line that connects those 2 angles together, and so the line that's not being related by those 2 would be line x. So we cannot prove x and y are parallel. Instead, we know that m and n are going to be parallel. So we would say that m is parallel to n. So m parallel to n, and we'd say by the converse of same side exterior angles theorem. Okay, what about 6 and 12? So now 6 and 12, our transversal would actually be n, because n is the line that relates those 2 together, those 2 angles together. So the lines that are being proven parallel are x and y. Now they're saying they're congruent. These are both corresponding angles because we have top right and top right. So they do have to be congruent, and they are. So we can conclude that x is parallel to y by the converse of corresponding angles theorem. Okay, and we can do that. Angles theorem if you want. It doesn't matter how much you show that. Okay, cool. Number 33. So we have angle 8 is 68 degrees. So that's going to be 68 degrees. Angle 12 is going to be 67 degrees. So the transversal relating those two is going to be line B. Okay. And then that means that we're proving C and D are either parallel or not parallel. But be careful on this one. They are alternate exterior angles, right? So they have to be congruent, but they're not. They're really, really close, but they're not quite right. So the lines are not going to be parallel. So our conclusion is that C is not going to be parallel to D by the converse of alternate exterior angles theorem. All right, so that's it. Pretty quick and easy. Tomorrow I'll give you guys the practice test, so just make sure you're caught up on all the homework. If you have any questions, you can join me at 11 any school day for our Google Meets. If not, I'll see you guys later. Have a good day.